In this part of lecture 1-2, we take a look at simplifying expressions. So what we did earlier was evaluate expressions. That's plugging in numbers for variables and seeing what the expression becomes. This part of lesson 1-2 is about simplifying expressions. So you'd be really surprised to see how often just rewriting an expression becomes a very, very valuable tool in algebraic thinking, being able to rewrite expressions in various ways. So the first thing we're going to do is look at simplifying using adding and subtracting like terms. So we're going to have two main tools here to rewrite expressions. The first is adding like terms or subtracting like terms, and the second is going to be the distributive property. So on like terms, what we mean by that is terms which have the same variables to the same exponent. So for instance, 5x and 7x are like terms. It doesn't matter what the coefficients are, as long as the variable and the exponent are the same. So 6.3x to the fourth, pi x to the fourth. So the coefficient what I mean by that is the number in front of the variable. So pi and 6.3 aren't nice coefficients, but since we have a variable x raised to the fourth power and this variable x raised to the fourth power, these are like terms. Now, 3x squared and 8x are not like terms because one of these is raised to the second power and the other one doesn't have an exponent, or in other words, it's an implied exponent of 1. We can rewrite things sometimes having like AB, if we divided this by an 8, well, 3AB over 8 is just like 3/8 times AB. So since we have A and B both raised to the first power, that these two are like terms. However, AB squared versus BA squared, here the B is raised to the second power, here the A is raised to the second power, so these two are not alike. Similarly, here we have an X, and then we're dividing by x. Even though we have an x here and an x here, these are not alike because one of these is being multiplied, the other one is being divided. We'll see later, specifically in chapter 3, that dividing by x is like having an exponent which is negative. By the way, when you have r squared c to the fourth t, and then somebody else mixes up the order of the letters, like c to the fourth t r squared, those are actually like terms. Just because the order's mixed up doesn't mean I can't unmix it up. Okay, in fact, there's this property when we multiply any numbers called the commutative property, which says that r squared times c to the fourth times t is the same thing as c to the fourth times t times r squared. So that's the commutative property of multiplication. So like terms that are alike, we're going to be able to combine. So for instance, like a 5x and a 7x, if I were to add those two terms, I would end up with a 12x. Now the other big property here in this section is the distributive property. And this says that if I wanted to get rid of parentheses, and I can't just simplify by adding a b plus c, what I can do is I can distribute, meaning I can multiply this a times both terms inside the parentheses. So the a can be multiplied times the b, the a can be multiplied times the c, and if I take a times b plus a times c, I'm going to get the same thing as I did if I took a times, in parentheses, b plus c. And you can just have the distributive property whether the a is on the left-hand side of the parentheses or if the a is on the right-hand side of the parentheses. So here's how it works. If we're going to simplify 5 times the quantity x minus 7 minus the quantity 3x minus 8, what I can do is utilize the distributive property. Now, in this case, the 5 would multiply times the x. 5 times x is just 5x. 5 times a minus 7 is a minus 35. Now, here's where it gets a little bit tricky, where people often make mistakes. This minus sign. This minus sign here is outside the parentheses. So I need to distribute this minus sign into the 3x and into the 8. When you take a minus times 3x, basically we think of this minus sign as an opposite. So this was a positive 3x. Now we're going to do an opposite of 3x, so minus 3x. Here we have a minus 8. If I'm going to do the opposite of minus 8, that's a plus 8. And so that's how we distribute. And then once we distribute, we say, okay, 5x minus 3x, let's combine those. 5x's minus 3x's, so 5 take away 3 is 2. So 5x's take away 3x's is 2x's. Minus 35 plus 8 becomes a minus 27. So that's how we do that. Now I'm going to go through the instructor-led problems here in section 1-2 on this part of 1-2. In order to do that, we're going to take a look at, I've already copied and pasted those into a Word document. I always type those in. So let's take this first problem. What I see here is a 2x and a minus 5x. Those are alike, x and x. So I take the 2 and minus 5. 2 minus 5 would be a negative 3. So I'm going to end up with negative 3x. Negative 6 minus 7 is going to be a minus 13. By the way, if you would rather do a plus negative 13, that's fine too. But minus for 13 is just a little bit easier to write. And that's it. The 3x, the negative 3x and the minus 13 are not alike. So this is as simple as I can make this expression. Let's look at number 2 here. 2x to the third plus 4x squared minus 3x plus 6 plus 5x to the third minus 8x squared plus 5x minus 2. So the x to the third and this x to the third are alike. So this 2x to the third and 5x to the third are alike. We're going to combine those. That'll give me, well, if I have 2x to the thirds and 5x to the thirds, that gives me 7x to the thirds. Now we move on to the x squareds. We have a 4x squared and a minus 8x squared. 4 minus 8 is negative 4, so negative 4x squareds. I have minus 3x's plus 5x's, so that's plus 2x's. And then I have a regular 6 and a minus 2. 6 minus 2 is 4. And so notice that in this case, when I simplified and combined like terms, I ended up with 4 different terms in my final simplified version of the answer. So there we go. Let's do number 3 here as well. So negative 12r, 13r, and notice I have also a negative 5r. So I have negative 12 plus 13 and minus 5. When you combine all of those, you get a negative 4, so negative 4 r's. And then I have a minus 6, a plus 16, and a minus 20. So you take negative 6 plus 16 minus 20, and you get a negative 10. So my final answer is going to be negative 4r minus 10. On number 4, we start with some subscripts here. Be very careful with subscripts. Some people will start combining these subscripts, but remember this x1 and this x2 are different. This is the first variable, this is the second variable. So when I'm combining like terms, we're going to combine the 12x1 here with an x1 there. By the way, you get 13 x1s because anytime you have just x1 by itself, like we do right here, there is an omitted 1 in front. You probably already knew that, but I just want to point that out. So when you just say x1, you're saying, well, I have 1 x1s. All right, so 13 x1s. How about x2s? We have 14 x2s minus 5 x2s. That gives me a total of 9 x2s. And then obviously we have a minus 7 and a plus 8. That leaves you with a plus 1. So your final answer would be 13x1 plus 9 times x2 plus 1. Problem number 5, that's where we get into the distributive property. Whenever I'm doing the distributive property, I always do it in 2 steps. I do my distribute step, 4 times 2x minus 3, 2 times 5x plus 6. So I'll do my distributive step, and then I'll combine like terms on the next step. So distributive step first. 4 times 2x, you just take 4 times 2, that gives you an 8. So you end up with 8x. And then take the 4 times a negative 3. 4 times a negative 3 is a minus 12. So 4 times 2 is 8. 4 times negative 3 is minus 12. Same thing. By the way, pay very close attention to the sign out front here. This is a positive 2. So when you multiply it in, 2 times 5x, this is positive times positive, right? What we went over in 1-1. 2 times 5 is 10, so you get plus 10x. This is a positive 2 times positive 6, you get a plus 12. So that's my distributive step. And then combining like terms would give you 18x. Now, when you do a minus 12 and a plus 12, those are going to cancel out and give you a 0. But whenever you're adding 0, that doesn't actually do anything to the answer. So I can just leave this as 18x as my final answer. Now, problem number 6, you can see here, 3a plus 4y minus 6a plus 4y. Distributive step. By the way, there's nothing out in front of this parentheses, so during my distributive step, I'm essentially just distributing kind of like a 1 there. I can just drop the parentheses off of this first part. So I just take 3a plus 4y, drop the parentheses off of it. And then here, notice we have a minus. This is where people who don't write this step get thrown off. They'll try to do this all in their head and they'll forget about the minus halfway through. So minus 6a, so minus distributes in to the 6a. Think of it as we're doing the opposite. So this was a positive 6a. We're doing the opposite, so that's going to be a minus 6a. This is a positive 4y. We're going to do the opposite. That's a minus 4y. Okay, you wouldn't. It's amazing how many people forget to distribute that minus into both terms there. And now I can combine like terms. So 3a minus 6a is a negative 3a. 4y minus 4y becomes a 0, so I don't have to write that. So there we are. Whoops. Negative 3a is the final answer to problem number 6. Now the last problem that is in section 1.2 instructor-led problems is this one. So let's distribute 5 times x1, 5x1, 5 times 4x2, 5 times 4 is 20, so you get 20x2, minus 7 times x1 is minus 7 x1, and minus 7 times positive 3 is a minus 21. Now in this, there's not a lot to combine, but there is these x1s that can be combined. So you do negative 2x1 plus 20x2 minus 21. And that would be the final simplified version of the answer. By the way, when the convention for writing these expressions is that when we have subscripts, you go x1 and then x2, sort of least to greatest. But when you have exponents, notice when we did this, we always wrote this x to the third, and then x squared, and then x, and then, so we wrote the exponents sort of in what we call descending order. The exponents go down. So that's the convention. That's not a necessary thing, but I just did want to point that out if you're wondering why there's a disparity. So the subscripts we write going up 1, 2, 3, 4. When we do exponents, we write in descending order 3, 2, 1. Again, that's just convention. If you mess up on that, that's not a big deal. I'm not going to count those wrong if you mess up on the order. But that's why I'm writing it the way I'm doing it. All right, so that is the end of this video and the end of what I'm going over on section 1.2. Remember, I want you to try these cooperative group problems on your own. If you're looking for practice to study with the exam, the at-home practice problems are there. And then obviously, as far as homework, if I assign it, comes from this graded homework 1, 2. All right, so that is it for this section.